In this tutorial, we are going to be continuing our discussion on Lewis dot structures, but now we're going to do it in a little bit more advanced. A lot of the steps are still the same. So the very first thing we want to do is count up our electrons. So here we have nitrogen and we have oxygen. We have 1 nitrogen and 2 oxygen. Now we need to figure out what those valence electrons are. Nitrogen's here, oxygen is here. 1, 2, 3, 4, 5, 6. So nitrogen has 5 and oxygen has 6. That comes out to be 17. But notice we have a -1 charge here. That means we're going to add 1 more electron. If it's negative, you add electrons. If it's positive, though, you're going to have to subtract electrons. So that means it's going to be 18 electrons total. Now let's arrange the atoms where the most electropositive, the least electronegative atom is in the center. So we have NO2, we have nitrogen, and oxygen. Oxygen's closer to fluorine, so it's more electronegative, so that means nitrogen's going to be in the middle. We're going to put oxygen on either side. Remember, we had 18 electrons. We're going to connect these two. We've used up 4 electrons now. So draw single bonds between each atom. So N, O, O, we need 18 electrons total. Remove the electrons used to form the single bond from the total valence electron count. Each bond is 2 electrons. So there's 2 here and 2 here. So it's a total of 4. So we have 14 electrons total. Place pairs of electrons around the peripheral atoms until octet is reached. So we have 2, 3, 4, 5, 6, 7, 8. That one's full. 2, 3, 4, 5, 6, 7, 8. So let's figure out how many valence electrons we used. 2, 4, 6, 8. 2, 4, 6, 8, 10, 12. We used 12. So we have 2 more electrons to play with. So let's redraw that. Started off with 18. We used 4 for the single bonds. We used 12 for the lone pairs. We have 2 electrons left. If any valence electrons are left, place those electrons around the central atom until octet is reached. So we have 2 more electrons left, so we're going to place them right here. Remove the electrons used from this step on the total electron count. Check for octet with each atom. So we have 2, 4, 6, 8. That oxygen's okay. This oxygen is 2, 4, 6, 8. That oxygen's okay. 2, 4, 6. We only have 6 electrons there. So therefore we are not done. Let's put that back up here because we're not done yet. If octet is still not reached, then multiple bonds must be used. Take a pair of electrons from each peripheral atom to form multiple bonds, and octet is satisfied for all atoms. Check again for the octet. So we have 2, 4, 6. We need 1 more set. So we're going to take away these and we're going to share them. Alright, so there is our base structure. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Let's try that again. Carbon and 2 oxygens. We have 1 carbon, I know it's going to be 4 electrons because 1, 2, 3, 4, 5, 6. And we have 2 oxygens. Those have 6 for a total of 16. Alright, so the least electronegative first. Carbon is the least because it's the furthest from fluorine. So I'm going to put that in the middle. So we've used 4 electrons here. Next step is to put in the lone pairs until we have an octet. We have 2 electrons, which means we need 6 more. 2, 4, 6. 2, 4, 6. Alright, we have now used all of our electrons. We have an octet on each oxygen. We only have 2, 4 on the carbon, so we need more electrons around the carbon. That last step said if you needed more electrons in the center, you take them from the lone pair and make double bonds. So 2, 4, 6 now. I still need 2 more. We'll take one from that side this time. So that means we have 2 double bonds. I'm rewriting it to spread those lone pairs out from each other. Let's try another one. We have boron and fluorine. 1, 2, 3, 4, 5, 6, 7. So we have boron and fluorine. 1 boron, and it has 3 valence electrons, and 3 fluorine, which has 7 valence electrons, for a grand total of 24. Alright, so here's boron, here's fluorine. Boron's less electronegative, so it's going to go in the middle, and fluorine's going to go around it. 2, 4, 6 electrons used up. That comes out to be 18. We need to fulfill our octet. We have 2 used, which means we need 6 more. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's 12 electrons total. We need 6 more. 3, 4, 5, 6. That's a total of 18 electrons. We don't have any more electrons. Let's check our octet. But wait, this is boron. Boron is one of the exceptions. It doesn't make an octet. It can only get up to 6. So we're good. We're going to try one more. And this one's going to be a little bit harder, because once again, this is an exception to the octet rule. So we have sulfur, and we have fluorine. 1, 2, 3, 4, 5, 6, 7. We have 1 sulfur, and it has 6 electrons. And we have 4 fluorine, and it has 7 electrons. So 28 plus 6 is a total of 34 electrons. Alright, now the next step is to put the least electronegative element in the center. Sulfur is the least electronegative. And then we put the others around it. That is a total of 8 electrons we just used. Subtract that out from the total, and we need 26 more. We have 1 bond, we need 2 electrons here, so we need 6 more. There's an octet there, octet there, octet there, and finally an octet here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That leaves us with 2 electrons left over. The next rule is to put it on the center atom if you have leftover electrons. Then check for octet. The fluorines have an octet. Sulfur has an expanded octet. It's actually more than 8. But that's okay. There's really no way around that. And for it to be stable. Alright, and there you have some more complicated Lewis dot structures.